In this 3 steps to sketch, we'll graph a shifted secant graph from the equation y equals 2 secant of 2x minus pi plus 1. Looking at this equation, we can clearly see shifting happening here with the minus pi and here with the plus 1. And so that's how we know we'll use the shifted method. All right, so now we'll take a quick look at the method outline and we'll get started with the graph. So here's our outline, a quick overview. This really helps us stay organized. In step 1, we'll find our companion equation and all of its essential information. So the companion equation is simply the reciprocal function. So we'll graph, instead of the secant equation, the cosine equation, since they're reciprocals. And we rely on this because it's likely if you're trying to graph secant graphs, you already know how to graph cosine graphs. So with one small extra step, you'll be able to get a really nice secant graph. In step 2, we'll plot that companion pattern lightly and we'll take care of the shifts. And then step 3 is where we'll create that reciprocal graph. So we'll just transform at some key points and then we'll sketch in the graph and repeat. So let's get started. So again, with step 1, we're finding our companion equation. All you need to do is replace secant with cosine. So our companion equation that we'll be working from is y equals 2 cosine of 2x minus pi plus 1. All right. Now we will start our analysis for our base graph. A, remember, is just that leading coefficient, so it's in front of the secant or the cosine here, so that's 2. That's going to help us get the y coordinates for some of our companion points for our maximum and minimum in step 2, so we'll come back to that. B is always the coefficient in front of x, so that'll be 2. It tells us we'll have 2 cycles of our graph between 0 and 2 pi, and we also use it to find the period or the length of one horizontal cycle. All you need to do is 2 pi divided by b. So we have 2 pi divided by 2. Our period is pi. And once we have all that, we're ready to set our scales for our axes. And so I like to be really intentional with the horizontal axis scale. Take the period and divide by 4. And this will ensure that step 2, when you first start plotting that companion pattern, each point will align with each of your horizontal tick marks. It just makes for a nice clean graph. So we'll count by pi over 4 for our horizontal axis, and for our vertical axis, 1 should work well. All right, so let's take a moment and label our grid. Starting with the horizontal axis, count by 1 pi over 4. So 1 pi over 4, 2 pi over 4 reduces to pi over 2, 3 pi over 4, 4 pi over 4 reduces to pi. With this method, that 4th tick mark moving to the right should match your period. It does. We are on track. 5 pi over 4, 6 pi over 4 reduces to 3 pi over 2, 7 pi over 4, 8 pi over 4 is 2 pi. All right, so we should see our 2 cycles happening within this horizontal space. All right, if you're working along with me, I'm going to pause, get the other side of this axis labeled. It's all the same values, just with negative. All right, so take a moment to double check. Here's what the whole labeled horizontal axis looks like. And the vertical one is easy enough. We're just counting by 1. So we'll get that labeled as well. And now we're all set up for our graph when we get to that in step 2. But before we do that, let's go ahead and identify our shifts. So we find our horizontal or phase shift calculating C over B. Before we do this, I like to just look back up at my original equation, or you can look at the companion equation. We have bx minus c, and we see that we do have a minus sign there. So I think that we should expect movement to the right, but I think it's important here to make sure that you get the correct sign for your value of c. In this case, our value of c should be pi. Okay, so c is pi. We know b already is 2, so our phase shift will be a value of pi over 2. And if you want to make a note that that's movement to the right, go ahead and do that. All right, then D is our vertical shift. So we see this +1 at the end, looking at whichever one you want. And we know that we will be shifting vertically up 1. All right, the final thing I like to do in the analysis step is to find the equation for all of the asymptotes of our secant graph. So there's a really quick way to do this. I will post a link to our playlist for secant graphing. It'll have a couple of videos with more details on this asymptotes equation. But for now, it's enough to just know what we should do here. You're basically applying the horizontal transformations of this equation to the parent asymptotes of y equals secant x. So just a little scratch work here. Take the inputs of your secant function, so that's 2x minus pi, and we're going to set those equal to those parent asymptotes of the secant function, and those are at pi over 2 plus pi k. Take a look at that graph if you need confirmation of that. And remember, k here is just representing an integer. We'll talk more about that in just a minute. So now all we have to do is solve for x. So start by adding pi to both sides. Okay, so on the left, we're left with 2x. And notice that we only add pi to the pi over 2 on the right side because pi k is not a like term. So if you need a common denominator, you could rewrite pi as 2 pi over 2. So we get 3 pi over 2 plus pi k. And then we need to divide the whole equation, both sides, by 2. So we're dividing everything by 2. We'll write our result over here in the asymptotes equation. So we should have asymptotes for our final graph that x equals 3 pi over 4 plus pi over 2k. And so again, k is an integer, and depending on what integer you substitute in, you'll get a different asymptote. So let's quickly sub in a few. If you let k is equal to 0, you'll see you should have an asymptote at 3 pi over 4. Let k equal 1. Get a common denominator there. Simplify, you should see that we'll have another asymptote at 5 pi over 4. If you let k equal -1, you should have another asymptote. This will be to the left of that original, and that one would be at pi over 4. So it's just a nice thing to kind of expect where your asymptote should fall for that final graph. I like doing it up front. It's a great way to double check. So we'll come back to that in our final step. All right, now we've done all our analysis. We've done all the hard work, the setup. We're ready for step 2, where we're going to plot our companion pattern. So we're essentially graphing the companion equation from the first step. Make sure you do this lightly, or in a different color. I'm going to use light blue. We're going to use this as kind of an intermediate graph for our final graph. All right, remember the cosine pattern starting out on the y-axis. It starts with a maximum, then an x-intercept, then a minimum, and then a final x-intercept for one cycle. Okay, so we will start that for this particular graph. And remember that you get the y-coordinate for the maximum looking at the value for a. Okay, so we know our y-intercept for this basic companion pattern, so mark lightly, will be here at 2 on the y-axis. All right, remember that your points for this base companion pattern should align with your horizontal tick marks, so move to pi over 4, that will be where your first x-intercept is. Move to pi over 2, we're going to have a minimum here, and you get the y-coordinate taking the opposite value of a. And then at 3 pi over 4, your next horizontal tick mark, you have another x-intercept. So you can kind of see that cosine pattern already sketching in here. And now we're ready to shift. And so we can do both of these shifts at the same time. Look back in step 1, we recorded that we should move right pi over 2. So that's going to be 2 grid units, and up 1. So 1 vertical grid unit. So for each of our points, let's go ahead and do this, and we'll mark it still in light blue, but with x's this time. So move right pi over 2 and up 1. So here's our new point. So do that for each of them. Right pi over 2, up 1. Right pi over 2, up 1. Right pi over 2, up 1. Okay, so again, you see this cosine companion curve. If you were graphing this companion equation, you would have your completed graph here. And we'll show that all the way up there. So there's one cycle. All right, now we're ready for this one additional step, step 3, where we take the reciprocal value. We're not literally taking reciprocals here, we just know how they transform from their original points. So think of it as point 1, point 2, point 3, point 4. Then we'll sketch in the graph and repeat. So starting with this first point, your maximum from your cosine companion, put a point there. That's going to turn into a local minimum for your secant curve. Your second point, that was originally an x-intercept. When you try to take the reciprocal of a 0, that's undefined. That's a great way to remember that you turn into a vertical asymptote here. And notice that's at 3 pi over 4. So looking back to our asymptotes equation, we should feel really confident that we are on the right track. All right, our next point, point 3, was our minimum from our cosine companion. Put a point there. That's going to be a local or a relative maximum for the secant curve. And then you have another, what was an x-intercept, turns into a nice vertical asymptote. And notice that that one's at 5 pi over 4. So again, those asymptotes are matching what we found from our asymptotes equation at the end of step 1. This one was when k equals 0. This is when k equals 1. So nice confirmation here that we have an accurate graph. All right, so let's sketch in this secant graph. Okay, we kind of have a broken secant cycle here, so we'll draw part of the curve. There's that curve that has the local maximum. And then we can sketch in another part of the secant curve here. That's kind of the matching side. That's part of the curve that has that local minimum. So there you have one cycle of our secant graph. And now all you have to do is repeat the pattern over and over again. So you can finish out this part of the secant curve right here. We have another asymptote at 7 pi over 4. We didn't actually calculate that one with our asymptotes equation, but hopefully you can see if you substitute in k is 2, that's how you can get that asymptote. And then we know that we would have another part of the curve that has the local maximum here. And then just work the pattern in the other direction. So finish out that part of the secant curve. We have another vertical asymptote here at pi over 4. We said that was when k equaled -1. All right, we have a point for our local maximum. So you can see we're just repeating this pattern over and over again. This asymptote at -pi over 4. Hopefully you can see that's when k is -2. All right, and just moving these curves in. Asymptote. Once you've got that first cycle of the pattern, you really are well on your way to having a very nice sketch. All right, so just finishing it out here, you can work as many cycles as you want. Just sketching in quickly. Practice plugging in different values of k to get these asymptotes. Hopefully you can see this would be k is -3, -4, -5. Kind of cool to see that. Okay, we'll put one final curve that has a local max, and there you have it. Like I said, you can double check that asymptotes equation to really make sure they're in the right spot. You can look back to your term B. We said 2 cycles should happen between 0 and 2 pi. So you can see here's a quarter, half, 3/4, 1 quarter, 1/2, 3/4, and a full cycle there. So you have 2 full cycles happening. You have a really nice graph. Hopefully this helped you understand the 3 steps to sketch method for graphing shifted secant graphs. Be sure to check out the links in the video description. There will be a lot more examples. Don't forget that there is more information on finding the asymptotes equation, and I'll post links to help you graph all the other trig functions as well. Thanks for watching.